Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh. Okay, so for today, we will continue on hypothesis testing for one population mean again, but today is for case of sigma unknown. Okay, so sigma unknown, and then our sample size is greater or equals to 30. So what test that we're going to use here is still Z, because the sample size is greater than 30. Okay, so same step as previous case. Okay, you should remember the 5 steps that you're gonna have to write in order to conduct hypothesis testing. The first step is state your null and alternative hypothesis, H0 and H1. Again, it have left tail, right tail, and two tail. And then second step is the test statistic. We're gonna use Z. Z equals to x bar minus mu naught over s over square root n. Okay, so the difference between today and yesterday is only at this part. Okay, we're gonna use S because the population standard deviation are unknown. Okay, and then the third step is critical value. So for the left tail, we have negative Z alpha, right tail Z alpha, and for the two tail, we have plus minus Z alpha over 2. Remember, you should divide alpha by 2 for the two tail case. Okay, and then step number 4 is state your decision rule. Okay, for left tail, reject H0 if Z less than negative Z alpha. For right tail, reject H0 if Z greater than Z alpha. And for the two tail, reject H0 if Z less than negative Z alpha over 2 or Z greater than Z alpha over 2. Other than that, we also can use a p-value approach. Okay, with the decision rule, reject H0 if p-value less than alpha. Okay, and then step number 5, we make a decision and conclusion. Okay, let's take a look into example 5. Okay. Okay, past experience indicates that the time for high school senior to complete a standardized test is a normal random variable with mean 35 minutes. A random sample of 35 high school senior took an average of 3.1 minutes to complete this test with a standard deviation of 4.3 minutes. Test the hypothesis at the 5% level of significance that mu equals to 35 minutes against the alternative that mu less than 35 minutes. Okay, so what are the information that given for us? Here is we have mu equals to 35, x bar, okay, sample mean equals to 3.1, we have n equals to 35, sample standard deviation 4.3, and we want to test at alpha 0.05. So this one is case number 2. Why? Because we doesn't know what is the population variance or population standard deviation. We just only has information on regarding the sample, and the important thing, we have n equals to 35, which is greater than 30. That's why we're going to use Z. Okay, so step number 1, state your null and alternative hypothesis. So H0 is equivalent to mu equals to 35 and H1 mu less than 35. Okay, it's already mentioned in the question. Okay, now calculate the test statistic. X bar minus mu divided by s over square root n. So we get negative 2.61. Okay, remember here, this one is left tail. Okay, and then find the critical value. Since this one is left tail, so you should put negative sign in the critical value. So we get negative Z alpha. Alpha is 0.05. No need to divide by 2 because this is left tail, right? So negative Z alpha equals to negative 1.6449. Okay, now how to come up with a decision rules. Okay, let's take a look at this diagram. So this is our rejection region, which the critical value equals to negative 1.6449. Okay, and then your test statistic value, we get negative 2.61, which is false in the rejection region. So yang saya shadedkan ni adalah rejection region. So value negative 2.61 is false in the rejection region. Thus, first we decide on our decision rules first. Okay, we reject hash not if test statistic is less than negative 1.6449. Okay, but we do not reject hash not if the test statistic is greater than negative 1.6449. Okay, so we can see from the diagram, negative 2.63 is less than negative 1.6449. So we reject null hypothesis. Therefore, the test is significant. And we can conclude that there is significant evidence to indicate that the mean time to complete this test is less than 35 minutes since we reject null hypothesis. Okay.